All right. So again, format 40, 30, 30. The short answer with 2 points each, so it's like the half of each. I do a lot with A and B in that section, you notice. And then for your response, choose 6 of 8. So out of those math topics, you could already kind of consider, not that you should do this, but if you want to focus on specific topics and kind of, I don't want to say disregard, but not necessarily focus on one of them in the math topics, that's kind of okay to do. It's not the end of the world. So for example, if you really struggled with the math problems on projectile motion, there's not going to be more than 2. There'll be definitely 1, and there'll probably be 1 with vectors. That's both in chapter 4. But there's not going to most likely be 2 on that. So if you decide, you know what, I'm going to already omit the math problem on projectile motion, that's okay. But keep in mind that you still have to make sure that you're studying it for the conceptual stuff, right? So although you might say, I really struggle with the math on that part, I'll let the math go, you got to understand the topics though, for multiple choice and short answer. But mathematically, think about it. If you're choosing 6 of 8, we've had about 7 topics, 7 or 8. So the most you can have from one topic is 2 problems. So you could think about omitting one topic when you're studying for the math part, if you'd like to. Okay? Just considering optimizing your time. That's why I say that. Now, if section them off like you see here, what is MC obviously? Anyone? Is that not obvious? I put multiple choice specifically, notice here, in all of these sections. So if you find that you want to really just practice multiple choice and you're really good at the math, and look at the stuff that says MC in each section. Okay, those are multiple choice from that section. There's not a lot from each, because your book does not have a lot of multiple choice, but I pulled any that were possible. Okay, so you'll see there's like 4 to like 8 in each of those sections. All the formulas are grouped accordingly. You'll be given the same formula sheet as always. And these are just sample problems in the text to look at. There's a lot of sample problems. You're obviously not required to do them. This is not something that's turned in. If you'd like to, if you did a lot of it and you want me to give you homework credit, I'll give you homework credit for it. I don't care. It's fine. So if you just submit it to Google Drive as midterm review assignment, but you don't have to do it. You're not going to lose credit. Okay? It's not like it's an actual homework assignment. I'll just give you like a 10 out of 10 as a homework assignment, which some of you could help if your homework average is a little bit low. So if you want to do a good amount of this and submit it. It's up to you how much you want to do. Okay? It doesn't bother me. It's up to you individually. Questions you have. This is obviously stuff that you want to review. Okay, the solutions to test 6 are not on Moodle yet. I'll add that today because everybody's taking it. But 1 through 5 are on Moodle right now for the mathematical ones. These are really good to study for practice for the midterm. You have problem sets, obviously. The solutions are there. Homework assignments, labs, and then any sort of example problems. When you're looking at your notes, the ones that we do at the very end of each section are the most complicated of the problems. Usually, sometimes I don't even give you problems in the test as difficult as that, so you shouldn't even expect them in the midterm. So when you're studying notes, look at the first 2/3 of the example problems when you're looking at difficulty. Okay? If you see some that are extremely lengthy and involved, it's probably not going to be that difficult on the midterm because of time. How long is the exam for you guys? An hour and a half, right? 2? Okay. Yeah, that's right. You can leave after an hour and a half, and it's 2 hours. Yeah. Time shouldn't be a concern, really. You could consider it to be like the length of probably 2 tests, maybe like 2 1/3. Time-wise, 2 test lengths would be an hour and 20 minutes or an hour and 30, depending on A or B day. So you still have a little bit of time left there. What do you want to look at? Which of these topics you want to start with? It's up to you guys. We have 2 days. We have today. We have a double period on Wednesday. On Wednesday, in the first period, you guys are lucky because you have a double. The other class doesn't. On Wednesday, in the first period, we're going to learn about power. So I'm going to spend the first period teaching you the topic of power that we skipped in chapter 6 when we ran out of time. In the second period, we're going to review for the midterm. The other class doesn't have it, though. So they have to watch the video on power on their own, actually.
Oh, is power on?
Power is going to be on the midterm. Yeah, it was not on your test, though. It was not on the test that we had.
Can we start with 4, 1, 4, 2?
Vectors? Yeah. Sure. So let's start with an example of that. And then how much energy did it require to actually fuse there? Okay, so keep that in mind. The format of the questions will be very similar to the ones you're seeing here. That's why I give you these samples. So we'll talk about for multiple choice and math for this, okay? So vectors, as far as multiple choice is concerned, you should know your components of vectors. You should understand that the cosine refers to the x component and the sine refers to the y component. Where does that come from? It comes from trigonometry, right? From your right triangle. So if you have a vector that looks like this, and its length is 8 meters, and its angle is 30 degrees, it's always got to be given with respect to the x-axis or the horizontal, the angle that's given. To remember these rules, if you're given the other angle, you would actually switch your sine and cosine for x and y. Now, if you're given something like this, you should recognize that right away this has 2 vector components. It has the horizontal component. Here's another color. And it has the vertical component. The vertical component is represented by the length of the vector, which is 8, times the sine of the angle, which is 30 degrees. The horizontal component is represented in this case by the length of the vector times the cosine of the angle given. Now, you have to have a calculator for sure on the test, right? You got to make sure you're in what mode for this? Degree mode, not radian mode. So if you reset your calculator, it defaults to radian mode. So if your battery gets taken out or something like that, because it happened on a couple tests, some of you had all the right work, but you were in radian mode. And I even wrote you a note. I only took off a half point because I'm like, this is right, but your calculator's in radian mode, so all the numbers are wrong. Okay? So if you reset your calculator, put new batteries in, which a lot of you do right before the midterm, some people replace them, it resets the calculator. So you got to go to mode and change it back to degree. Okay? Be careful with that. Now, multiple choice wise, a question could simply be asked, determine the horizontal component of the vector given in the diagram. So you go ahead and type in your calculator 8 cosine 30. Or determine the vertical component, 8 sine 30. And you get a number. Okay, you're not going to actually express it that way. Or maybe I would ask you something like, which of the following trig functions is associated with the horizontal component of a vector when the angle is given between the horizontal and the vector itself? And the answer would be cosine. If it's talking about the problem and it says which of the following is the y value, the answer would be sine. Now, as far as this is given on the math portion, right? Because you need this concept for forces and for projectile motion. If a projectile is launched with a given velocity, say 80 meters per second, at a given angle, you have a vertical component and a horizontal component. So this is going to be used in force problems and in projectile motion. But specifically, vectors in mathematical problems, we did examples where it had like people walking and moving, and you had to track their path and find the final displacement from beginning to end. So a simple example, just because of time, right? Instead of doing a lot with this one, it could be a little bit lengthier, would be a person walks 4 miles east. Person walks 4 miles east and then turns and walks 3 miles northeast. Which way is northeast? Good. So you go north and then you go east, right? Think about it. And then works 3 miles northeast at an angle of 20 degrees. Determine the person's overall displacement. Okay, the 3 miles is in red. I should actually move that like that. Determine the person's overall displacements. So what would I do here? How would I approach this? I know some of you know this because you did it really well on the test. What do you got on the test?
Well, you can do first the sine of 3 sine 20.
Why?
Because you need to find the vertical
And the?
displacement and then the horizontal.
Good. Look at any of the vectors that are given at an angle. How many of them are at an angle in this diagram? How many? Everybody.
1.
Just one, right? So you only have to break one of them down into components. The other one, is that in the x or in the y? Is the 4 miles in the x or in the y? X, okay? So we know that 4 miles goes in the x already. Oops. So we could start and we could say, well, we have our x component and we have our y component. And I did this with a table. Do you remember I showed you a table method? You can definitely use that table method. That's fine. I'm going to do it quickly here with just x and y written this way. But the table method works perfectly. It's exactly what I'm doing, really. So in the x, I've got 4 miles for sure. Why isn't the 4 miles in the y direction? Because it's only to the right. If it was up or down, it would be in the y direction. If it was left or right, it's in the x direction. Now, the vector that's 3 miles is in the x and the y. So we go ahead and break this into components right here. So take a look. This is the x component. This is the y component. You have to do what you just did over here. So you have to do 3 cosine 20, and that's going to go added onto the x component. And then 3 sine 20 is going to become your y component. Does that make sense? Break this vector here into 2 lengths. I'll draw them. This is the x component of the vector right there, and that's represented by 3 sine 20. So if I want the overall length that this person moved in the x, I would add these 2 numbers together, right? Segment addition postulate, geometry. Two segments next to one another can be summed together. it's common sense, right? You walk 5 miles, and you're all giving me looks like, oh my God, it's geometry. You walk 5 miles, you walk 3 miles in the same direction. How far have you walked? 8 miles. So literally take this 4 miles here, take this 4 miles, and add 3, I put sine. Jeez, I'm terrible today. Sorry, guys. Cosine 20. Over here, 3 sine 20. Now, when I add them together, I'm going to get a decimal. I'm going to approximate it to the nearest tenth. Okay, why don't I have to add anything to the y component? Explain that. Explain why the y component only has one term in it. Yeah, it's 2 factors, but this is one term only. How come there's only one? Yeah, look at the diagram here. The only y vector is right here. Everybody take a look. There it is where I'm highlighting. In the x direction, this person walked 4 miles, and then he kind of walked like this, and then up this far, instead of taking the 3-mile route there. Remember, the whole idea is that you break every vector into x and y. Every vector. So add these two together, and then move up, instead of taking this route, which is the actual route the person took. Now, once I get the x direction and the y direction, what am I actually trying to find, though? What's the goal in this problem? Same 2 people. What's the goal? What am I really trying to find? R, very good. I'm looking for R, which is the resultant. So I want the hypotenuse. What does that trigger in your mind? When you're searching for the hypotenuse, what should you use? Pythagorean theorem. So the total x length is this, square that, plus the total y length, which is this, square that, and that equals r squared. You also really want this angle right here. That's the angle theta. You can get that by recognizing that you have opposite and you have the overall adjacent. You could do the tangent of theta equals opposite over adjacent. Did anybody actually calculate numbers while they were sitting here? We could do this if we have numbers. If not, we don't have to continue. We can go to the next topic. I'm just trying to instruct you on how to do it. Who asked this question to start? Gabe. Does this make sense so far, the x and the y parts? This is the first beginning here, and then this is just a small piece of it. We have to come up with numbers to make sense, though. It could be anybody, obviously, guys. I just want to get numbers here. What do you have for x? 6.81. Or you can do 8.2. That's fine. And then 3 sine 20. What do you got, Gabe? 2.81? Are we sure? One of those is off. Because that would mean 3 cosine 20 is 2.81 and 3 sine 20 is 2.81. Did you use cos or sine, Gabe? Check yours real quick. Yeah. Try sine there. What do we got, Ernest? What'd you say? 1.02. If you didn't get this number here, by the way, it means your calculator is probably not in degree mode, because there's no other way to do this. Right? If you type in 3 sine 20, you got to all get the same answer. 1.02? Okay, if you don't get that, check your mode, and it's probably in degree. It's probably in radian mode when it should be in degree. Now, that's the x and the y vector. So what do we do now? We take those values, and we sum their squares.
Wait, why do you do that?
So why do we sum the squares?
Yeah.
Because we're looking for r. Look at the diagram.
Oh, yeah, you're right.
So since we're looking for r, which is in this diagram here, we take the base squared plus the height squared equals the hypotenuse squared. Base squared plus height squared equals hypotenuse squared. I'm doing it at the very bottom. I tried to move this up, but it all started moving in separate pieces. Let me see if I could do it better. Hold on. There we go. Okay? So again, the base is 6.81. The height is 1.02. That's the x is the base. The height is the y. Sum the squares equals r squared. So you'll get r squared equals some number. How do you get r? When you have r squared equals some number. Square root. So r is equal to the square root of whatever this was over here. What do we get as a final answer for r? A final answer for r.
6.88.
Which makes sense, and let's explain why. It's in miles we were given. It's barely bigger than the 6.81 because the 1.02 is not very far. So by taking the hypotenuse instead of moving the other way, yeah, you're getting rid of the extra mile pretty much. You don't have to go much further than you would have gone if you did it separately. Okay, so this person walked. What was this person's distance? How far did they travel in distance? Follow the path, please. Everybody look, if you don't know what I'm saying, follow the path. What's the distance traveled? This is the actual distance. See what I'm highlighting? What's the distance? It's very simple. 7 miles. The person really walked 4 miles and then 3 miles. You all see that? It's really 7 miles. But if this person had taken the displacement instead, he or she would have saved only 1/10 of a mile, 0.12. See what I'm saying? This is just a little bit less than 7. So in this case, walking 4 miles this way and then 3 miles this way is not really that bad. It's not much more effective to take the hypotenuse if you could, because you don't save much. You end up going 6.88 miles by going direct instead of 7 miles by going this way. Okay? Again, the path taken is blue and then red, but the actual displacement is R. We looked at the full length of the base and the full length of the height to get R. It doesn't mean we took that route. This route was not taken ever. This would be the longest route, wouldn't it? You'd end up going 6.81 miles and then 1.02 miles. That would be not a very direct route at all. You'd rather take this route. It's like crossing the street, right? How many of you at a stoplight before have been like, you know what, I can cross this way and then cross this way, but if there's no traffic, what should you do? That's what this problem is talking about pretty much. Why would you walk across the street and then across another street? If there's no traffic, you go diagonal. This is the shortest route. This is the displacement. Yeah?
So I'm still confused. How do you get 6.88?
You take this is the base of the triangle. This length is right here, 6.81.
Yeah.
The height of the triangle is the y value, 1.02. And Pythagorean theorem, a squared plus b squared equals c squared. Here's a squared plus b squared equals c squared.
Oh, which is...
This becomes a number, and then how do you get rid of the square? You square root it. So I didn't show the work, but you got to just get the number and then square root it. Jake?
So on the test, for the triangle, like the original triangle, would we be given the sides or not?
So you would be given the words. So here's how the problem would read. A person walks 4 miles east and then turns to walk 3 miles at 20 degrees northeast. That's what it would be given as. Determine the actual displacement of the person. All right? Yeah, it most likely will not give you diagrams on this stuff. Okay, it'll be words. You have to come up with the diagrams. Yeah?
So the majority of the problems are probably word problems.
For the math part, they're going to be all word problems. I really don't ever give you diagrams in those, if you notice. That's part of the problem, is dissecting it. If I think it's extremely complicated, maybe I'll give you a diagram. But if it's one of my normal level problems, I wouldn't give a diagram. What else? So that's a good example. Good question, Gabe, on vectors. What else? Yeah.
Since we're already on it,
Yeah.
we were problem with that table, not with vectors. I think it was vector.
Projectile motion. Yeah, but it involves vectors, which is good. Let's do projectile motion, okay? Again, one of the more difficult topics of the year. I know some people struggle with this topic a lot. So again, I'm not saying I don't encourage that you just ignore a topic to study, but mathematically speaking, you could rule out one topic for the math part. So if you want to rule out a topic, you might want to rule this one out if you struggle with it. Okay, you probably only have one question on the test on projectile motion. But still understand the ideas and the theories for the mathematical or for the conceptual parts.
Can we do this one in the table?
Yeah, it's going to be X and Y, and we do the split. Yep, absolutely. So let's say that an object is launched. An object is launched from a height of 200 meters. Some of you like to type this, so you can if you like, or you can draw diagrams. And I don't want to draw it right away, though, to give it away. An object is launched from a height of 200 meters above the ground. An object is launched from a height of 200 meters above the ground. If the initial velocity is only 5 meters per second, at an angle of 15 degrees above the horizontal, 15. If the object is only 5 meters per second, I think I said, at an angle of 15 degrees, determine, let's see, what do we want you to determine? It could be 3 things, really. Determine the horizontal displacement and time of flight.
I was least sure.
Determine the horizontal display. That's what was around the chair. And time of flight. Yeah.
If you're given a problem like that with an angle, like, isn't the first thing you should always do, like, do 15 cosine?
Was it 15 I said or 5? I forget which one. 15.
15 cosine.
So, yeah. Absolutely, Jake. Very good. So,
You said 5 meters per second with 15.
the angle is 15, so it's gonna be 5 sine 15. It was 5 meters per second, right? Okay. So again, we've got an object is launched from a height of 200 meters. So right away, this is what you should have drawn. Where is it going to land? Where do all things land? On the ground. So what's the displacement vertically going to be? What is it? Negative. See that? That's the key here. If you forget this, it's not going to work. So on your XY chart, you need to write negative 200 meters. What's the acceleration in the y direction always? Yeah. Projectile motion, remember it's down, so the acceleration is negative. Okay. Now, from the diagram, I also need to figure out, what am I looking for? I'm looking for x, that's unknown. It said, what is the horizontal displacement? So that's an unknown. What else would I indicate? Go ahead.
We look for T.
Time. In both cases, I'm looking for time, right?
Yeah.
So what would we call that? Our what? Linking variable. Just like normal force was the linking variable you could use in both directions. What's the one thing I have not included yet? And I'm purposely not doing it just yet.
And then we should give the velocity.
Yeah, the velocity. So let's talk about that. Jake already mentioned it, but this is where vectors really come into play. You need to break up the velocity into its horizontal and vertical component of velocities. Because as this object moves, remember, follow me if you can, please. Your object is launched, right, initially. It's launched both out and up at the same time. So watch, here's the path. And then eventually it gets to the top, right? When it's at the top, it stops moving vertically for a second, right? It was going up, and then suddenly, where is it going? Down. But which way is it moving the whole time? To the right. Remember, the x velocity is always the same. There's no acceleration in the x direction. So Vix is the same thing as saying V bar x. If you recall, we wrote down V bar x a lot, and we would say, okay, that's just whatever the velocity is, which was 5 meters per second, times the cosine of whatever the angle was, which was 15 degrees. And again, the acceleration is 0. There's never any acceleration in the x direction. Pretty much we're assuming there's no resistance to the air. There's no wind at all. There's no combative force as the projectile moves. How about the y direction? What do I write? Do I write V bar y? What do I write in the y direction? I don't think it was V bar y. What was it?
Wasn't it V?
Yeah, in this case though, VIY. Okay, it's initial. So that's going to be 5 times the sine of 15 degrees. If you have trouble seeing where this comes to play a role, let me draw it in the diagram. So here's your actual object launched. That's the velocity vector right there. The object is launched at an angle, so it will follow that parabolic path. Okay, let's draw the path of this projectile, just so we understand it real quick. Let's talk about some theoretical stuff. When it gets to max height, we already said that the velocity in the y direction is 0. All the velocities in the x direction. But along the way, what doesn't ever change? What's the one thing that's constant in this problem? I said, again, the x direction velocity already is. But what else is the thing that's constant in this problem always? Acceleration. And that's a problem that I feel like is asked a lot on subject tests for SATs. It used to be for the New York State Regents. If you're a public school, the New York State Regents exam for physics always asked it. It talks about how velocity and acceleration vary. Acceleration is always the same. Some of you are still misleading or misconstruing that concept. This is not going to change. The velocity is what's changing. As the object falls to the ground, it accelerates the whole time. Yes, realistically, it reaches terminal velocity eventually, and then it just coasts down the whole way. But this is not changing. This is a constant on Earth, right? That's the value on Earth. The velocity is what is changing. So what are we trying to find? We're trying to find the horizontal displacement, and we're trying to find the time. Which one should we find first? How come?
Because you can utilize when you do the formula there, you can utilize that and the b x over t, which is a lot simpler.
Yep. Look over here. So right away, that's how you recognize you've got two variables here. You're going to have to utilize time from the y direction and the x direction. So literally just look at your setup. Look how many question marks. See there's two here? Can you solve when you have two variables and only one equation on this side? No. So you automatically start on this side. I'm hoping that because you're doing this a second time now, so not relearning it, maybe it's a little clearer. Because we already did, remember, forces with normal force? So this is very similar, where we would find the normal force and then plug it in for the force of friction over here. So now we're just doing it with time. What equation can be used that has these four variables? And I need you all, I'm not going to get the answer yet. I need you to stop and actually look. Look at your formula sheet if you don't know the answer right away. Practice this. There's one equation that you can use that relates y, a, v, and t. And remember, on the formula sheet, it's not listed as y. What is it listed as? What is it listed as? X. The formula sheet says everything in terms of x. You need to recognize, open your formula sheet if you don't know what I'm talking about. You need to recognize that although it says x on the formula sheet, all of those formulas work if you just replace y. Is that clear? You have 3 or 4 formulas there. If you're not sure and you're having trouble loading the formula sheet, this is what they say on the formula sheet. All of these formulas can be used wherever you see an x, put a y in. Wherever you see vi, it could be viy. Vf could be vfy. So what do you got, Ryan? Which one do you think?
First one.
The first one. How come, Ray?
Because there's the F is not even involved in the problem, so you don't use it.
Because what is that?
The F is not.
Good. Ryan recognizes right away these both involve VF. Are we given VF? No. Are we looking for VF? No. So we don't have to worry about those problems or those formulas. So I would agree and I would use this one. Now again, instead of writing x equals, we're going to write y equals. Ernest.
I wouldn't even use, because for the y isn't v of 0.
To the top it is, right?
Oh.
Where are we looking? The whole problem, right?
Yeah.
If this problem were symmetric, you may want to do that to the top and then double the time, right?
Yeah.
But is this symmetric? Starts at a cliff. So if a problem, Ernest makes a great point, guys. If a problem starts here and you want to figure out the time to the end, you could set VF equal to 0, and that gives you the time to the top.
Yeah.
VFY rather, right? And then you can double that time. But this problem is not symmetric. It starts here and it ends down here. Okay? Great question. It's very useful to do that. If you're trying to find a problem that starts on the ground and ends on the ground, just to use VFY equals VIY plus AT, find the time to the top, and then just double it. Okay, that's a good technique. So if I recognize in this problem that I'm looking for time, what do I notice right away I need to use? Anybody pick up on it? Not substitution. I need to solve for time. Come on, look at the equation. What am I going to have to use? The quadratic formula. Or type in the quadratic program if you don't have it by now. I put it on Moodle. It's on there. You can type it in and just run a program to do it. Or you can graph. Your math course now, you know. X-intercepts are solutions to equations. Well, look at this one. Just move the 200 over and type that in y1. Don't actually do all the work. Why would you do the quadratic formula? It's so much work. Move the 200 over, type this into y1. Wherever you see a t, instead of a t, what do you put in the calculator? X. Find the x-intercepts of the graph. Those are your times. Okay, one of the times would be negative, one would be positive. Which one I care about? Which one? The positive time. So move the 200 over by setting it equal to 0. I'm going to put things in order. I don't have to really do what I'm about to do, but I can. Okay, the order does not matter. But if I recognize here, this here is really negative 4.905. That's a number that repeats itself a lot, so you probably know it by now. What does 5 sine 15 turn out to be again? 1.29?
That is another one.
This cannot be factored. Don't try and factor it. You're never going to factor in physics, unfortunately. Well, at least quadratics. Okay, so type this in, y1, and see, well, when is y equal to 0, which means when are you at the x-intercepts? Right, this says, when is this function equal to 0? Or where are the x-intercepts, is what it's asking. So if you have trouble with this, maybe you can go ahead and look on Moodle. I've also put a video about how to solve quadratic equations using a graphing calculator. All right, I'm not going to go through that process. It's going to take us 10 minutes to go through that. Anybody get the numbers? Anybody got them? Either via quadratic program, quadratic formula, or via graphing. Any of those are acceptable. It doesn't matter. We don't even need the numbers, so I'm not going to do it. Ready? So we're going to get a negative number. Please follow along. We're going to get a positive number. Which one am I rejecting? Okay, the negative time doesn't matter. Now, I take this answer from the y direction, and what am I looking for still? The horizontal displacement. There is only one formula we ever use for the horizontal displacement or the horizontal direction with projectile motion. The only equation we use involves x. There's only one of them. Okay, v bar x equals x over t. If I want to get x by itself, how do I get rid of time? It's currently dividing. Opposite of division, multiplication. Multiply both sides by time, and you'll get the x value. So whatever this answer was here gets plugged in for time. Whatever v bar x is up here gets plugged in for v bar x. Once we plug in those two values for v bar x and time, that will give us the horizontal displacement. Please write this down if you didn't know that. This is the only formula you're going to ever use in the x direction for projectile motion. Why is this the only formula you'll ever use? How come? This is the only formula you'll ever use, Juliet. There's no acceleration. This is the only formula that doesn't involve acceleration. If you wanted to drop off acceleration in this formula, they become the same formula. Take a look, everybody. Drop off. This is what Ernest, you asked us earlier in the year. Ernest, use this formula in the x direction, which you can. And what's the acceleration? 0. So here, look. This is what remains. This is the exact same thing. Y, x, vi, vi, t, t. Same formula. So if you want to use this formula, that's fine. Just drop off acceleration. But you end up with this formula inherently anyway. You got the times? What do you got?
The negative one is 6.17.
And the other?
Let me just move.
Matei, give us the important one. Who cares about the negative time, man? What do you got?
6.6.
6.6. So we take 6.6 seconds. Now you use second, trace, find the 0 of the function. There's an exact way. Don't use the trace. If you're just moving the cursor, this is an estimate. There's a real exact value if you use the 0 command by second trace. And then find the 6.51. Yeah, there we go. There's our answer. Not 6.6. Matei, man, letting me down here. I'm just messing. All right, so 6.51 is the exact value. Take 6.51 and plug it in over here in the x direction, 6.51, and then 5 cosine 15 goes in right here. Multiply those numbers. What is your answer going to have as far as units for x? Units. What are the units for x? Meters. X stands for? What does x actually stand for, though? Displacement, which is measured in meters. Horizontal displacement. We got about 8 minutes. It's an A day, right? Why is it a B day?
There's a game.
I know, and it's midterm review. Why does it have a B day?
I think it's a B day all week.
Is it really?
Don't take my word for it.
Can't take it. No, can't. Yeah. Well, guys, listen to the question. Listen. Chow posed the question as following. When would you start in the x and move to the y? If you were given the horizontal displacement, maybe, x, then you would have horizontal displacement, you would have v bar x, you could find time, right? And then maybe you were trying to find the height of the cliff. So if I told you the horizontal displacement is 100 meters, find the height of the cliff, you plug in 100 here, you have v bar x that was given, solve for time, move that over, and find the height of the cliff. Great question. Okay, because it could be one of those two, really, right? So those are the two possible ways this could be asked for this kind of a question. Yeah.
This one comes with 3.25.
for 5 sine 15, and your mode is on.
That's mine.
It's all reading, guys. Yeah, really? Yeah. It's all reading. Good degree. It's like the first thing you check. Did you not check? Hit enter one more time. Okay. All right, so we got about a minute. So listen, tomorrow I don't meet with you guys. I am about halfway through your tests. At this point, you should have a video uploaded, the mathematical stuff done. If you haven't, you can still do it. It's just going to be late. Okay? I'm going to take off 10% each of those days that it's late. So it should be in there at this point. Now, if for some reason one person is working on the written only, I don't know why you would do that, but apparently people are breaking things up like, yeah, you just do the written. You're still putting all 4 names, but you're submitting it to one of the Google Drive folders. It doesn't matter which. The video in one of the folders, not all 4, please. The mathematical portion in one of the folders also. It doesn't have to be in all folders, but put your name on all 4. Okay? I'm going to email you a quick email. You're going to reply to it at some point. So check your email for a quick, not survey, but a questionnaire. Okay, you're each going to reply to me, and it's annoying that I'm going to have to answer 40 emails, but I will. Okay, so please check your email. You have another day in between this, so Wednesday, come prepared maybe with some questions you want to ask. Yeah, Jake.